so far, these are the transformation rules we have talked about. We've talked about how to vertically shift a graph either up or down. We've talked about how to horizontally shift a graph either left or right. And then we just got done talking about reflection. So you can reflect your basic function either about the x-axis or reflect it about the y-axis, or you can even reflect it about the origin. There is one more set of transformation rules where you're going to learn. Those are on page 8. These are going to entail vertical and horizontal stretches and compressions. So if you look on page 8, there is a box of information here that basically describes the transformation rules for these vertical stretches and compressions, and then you see some rules for horizontal stretches and compressions. And to be honest with you, these rules are kind of confusing if you read through them, okay? I think the best way to learn this particular set of rules is to just jump into an example. Okay, so this box will be here for reference if you need it, but again, it may be a little bit confusing because it's kind of mathy. So let's go down and take a look at example 5, okay? So the first thing I want you to realize about example 5, this graph that has been given to you is not one of the basic functions that we learned in section 3.4. Okay, this is not x or x squared or x cubed or the absolute value of x or the square root of x or the cubed root of x. It's not those guys. This is a random parent function. Sometimes we call the basic function the parent function because we're going to generate all the other graphs from it. This is a random graph. And from this, you're going to have to do the transformations. Okay, I'm going to be quite honest with you. This is my preferred way of asking you questions on exams regarding transformations, okay, to give you a random parent function. That way you can't pop this thing into the calculator and I can truly see whether or not you've learned the transformation rules, okay? So guarantee you when it comes test time, you will get a transformation question where the parent function is a random function. It's something you can't pop into the calculator. So that's why it's very important that you do learn your transformation rules. Okay. All right. So this particular graph that we have, it's basically 3 line segments connected. And there's 4 points that are emphasized here. Okay, so again, to do the transformations, we're going to concentrate on moving those 4 points, and then the whole graph will move as a whole. Okay, so let's talk about what the transformations are going to be here. You can see in part A, we're going to be we're going to try to draw the graph of y equals 2 times f of x. In part B, we're going to find the graph of y equals 1/2 times x. In part C, we're going to do y equals f of 2x. And then in part D, we're going to do y equals f of 1/2 times x. Okay. This is what I want you to realize. Okay. These equations are not transformations that we have seen in this section yet. Okay. Remember, if you are doing a vertical shift, you're moving up or down, you would be adding or subtracting a number outside of the function. Okay, that's not what's going on here. Okay, if you were doing a horizontal shift, meaning moving left or right, you would be adding or subtracting inside the parentheses. Again, not what's going on here. If you were doing some type of reflection, it would involve a negative sign. We don't see any of those. So all the transformations that we've learned so far in this section, that's not what's going on here. This is a totally different group of transformations. Okay. All right. So what we are doing, we are multiplying by a number. Okay. So here we're multiplying by 2. Here we're multiplying by 1/2. Here we're multiplying by 2. And here we're multiplying by 1/2. Okay. It is happening in a couple of places. In parts A and B, the number is being multiplied on the outside. And then in part C and D, the number is being multiplied on the inside of parentheses. Okay, so when you're multiplying by a number, that is going to be indicative of a vertical or horizontal stretch or compression. Okay, so we're just going to kind of talk about which situation is which equation. Okay, all right, Let's start with example A. A and B are actually kind of easy. C and D are going to be a little tougher. Okay, so just to warn you. Okay, I will color code these. I will put each one in a different color so you can see what it is. Okay, I'll start with this guy, part A, in blue. Okay, so what I want you to do, like I said, we're going to take each of these 4 points that are emphasized and we're going to move each one of those, and then the graph as a whole will move. Okay, so we have, okay, this graph that we've been given, that is f, and we're trying to graph 2 times f of x. Okay, the y equals here, I don't want you to, worry about that. We are trying to graph 2 times f of x. Okay, so I need you to think about it this way. Okay, we have learned in this class that f of x is the same thing as y. Okay, so that's why I scratched out this other y. Okay, so this is really saying 2 times f of x, that's the same thing as 2 times y. Okay, so what's going to happen to graph this first equation out, this first transformation, you're going to go to each of these points and you're going to multiply the y value by 2. Guess what happens to the x coordinate? Nothing. Okay, you only change the y coordinate. Okay, so here what we're going to do, I'll write it in words. So we're going to multiply the y value by 2 and we're going to leave x alone. Okay, so let's do this. Okay, maybe I'll go ahead and make like a little table here. Okay, so I'm doing this graph in blue, so everything I do for this graph will be in blue. Okay, all right, so our original points here are -2, 0, 0, 2, 2, 2, and then finally 4, 4. Okay, so these are the original or old points, and then we'll talk about what the new points are going to be. Okay, all right, so if we're starting with this point, -2, 0, okay, you're going to leave the x coordinate alone, and then you're going to multiply the y coordinate by 2. 2 times 0 is 0. Okay, so it's going to stay put. Okay, and then we do the same thing for the next point. For 0, 2, the x coordinate will stay the same, and we're going to double the y coordinate. Okay, so that'll 2 times 2 is 4. Okay, so we're going to go to 0, 4. That's this point. Okay, so this point right here has moved up here. Okay, then we have 2, 2. To transform it, you're going to leave the x coordinate alone. You're going to multiply the y coordinate by 2. So 2 times 2 is 4. Okay, so 2, 2 will move to 2, 4. That's right here. Whoops. Hello. All right, right there. And then lastly, you have 4, 4. You're going to leave the x coordinate alone, and then you're going to multiply the y value by 2. 2 times 4 is 8. Okay, so the point 4, 4 will go to 4, 8, which is right here. Okay, so all 4 of the points have moved. And now we're just going to connect the dots with the same basic shape. Okay, so I'm going to start with this point, and I'm going to connect it up here. And then I'm going to connect these 2 dots like this, just following the same basic shape as the original graph. And then lastly, I will connect this pair of points. And that's it. We're done. Okay, so this is the graph of 2 times f of x. Okay, if you're comparing the black graph to the blue graph, you can see that the black graph, the original graph, has been stretched vertically. Okay, so this is a vertical stretch. Okay, that's all you had to do. Okay, so let's go on to part B. Okay, I will put that one in red. It is similar. Okay, I'm going to scratch out the y equals, but it's a number times the function. So it's 1/2 times f of x. So if we're dealing with 1/2 times f of x is the same thing as y. So this is 1/2 times y. So again, what we're doing here is we're going to multiply the y value by 1/2, and we're going to leave the x value alone. Okay, so I'll write that up here. We're going to multiply the y value by 1/2, and we're going to leave the x alone. Okay, so I will do that over here as well. Okay, so I'll make a list of old points and new points, and I'll put these in red. So again, we've got the same original points. So we've got negative 2, 0, 0, 2, 2, 2, and then 4, 2. Okay, and then we'll set up our new points. Okay, so again, what you have to do is you have to multiply the y value by 1/2. Okay, and you need to leave the x coordinate alone. Okay, remember, if you are multiplying something by 1/2, that's the same thing as dividing by 2. Okay, so you can do it either way. Either take your y value and multiply by 1/2, or just take it and divide it by 2. Okay, all right, starting with the point negative 2, 0, which is right here. Okay, the x coordinate's going to stay the same, and then we've got to take the 0 and multiply it by 1/2. 0 times 1/2 is 0. Okay, so again, this point stays the same. Okay, now I'm going to take a look at 0, 2. Okay, to transform it, the x coordinate will stay the same, and then you need to multiply the y coordinate by 1/2. 1/2 times 2 is 1. Okay, so this is going to go to 0, 1, which is right here. Okay, next, the point 2, 2, which is this guy. Okay, you're going to leave the x coordinate alone. You're going to take the y coordinate, which is 2, and you're going to multiply it by 1/2. 1/2 times 2 is 1. Okay, so this point is getting moved to 2, 1 right here. Okay, lastly, for 2, you're going to leave the x coordinate alone, and then you're going to take the y coordinate of 2. Actually, it's 4. I wrote it down wrong. Okay, we're starting with 4, 4 here. Okay, this point, the original point in black. So we're going to leave the x coordinate alone, and then we're going to take the y coordinate, which is 4, and we're going to multiply it by 1/2. 4 times 1/2, that's the same thing as 4 divided by 2. That's going to give you 2. Okay, so this point right here will move to 4, 2. Okay, and that is right here. Okay, we're going to connect the dots with the same basic shape. So we just need to go from left to right and connect each pair of points with a line segment. All right, so let's do this. So here we go. We're going to connect these two guys. And then we're going to connect these two guys. Should be a flat line right here. And then we're going to connect these two guys, and then we will be done. Okay, so this red graph is the graph of 1/2 times f of x. Okay, if you had to describe in words how the black graph compares to the red graph, this is a vertical compression. Okay, you have stretched it, or you've shrunk it in the y direction. Okay, so this is a vertical compression. All right, let's take a look at part C, okay, and actually part D, okay. If you just at a glance look at part C and part D and you compare it to parts A and B, you notice that in part C, you're multiplying by 2, just like you did in part A. However, you're now multiplying inside the parentheses. And then same thing with part D. You are still multiplying by 1/2 like you did in part B, but now the 1/2 is inside parentheses. Okay, so what's going on here, you need to realize what happened in parts A and B. We multiplied the function by a number on the outside. Okay, so essentially your y values were getting multiplied by some number. Okay, so your y values were changing. Okay, so you were getting either a vertical stretch or a vertical compression. So now that you're multiplying by the number on the inside, okay, the x is what's getting multiplied by the number. Okay, so you've got 2x and you've got 1/2 x. So now it's either going to be a horizontal stretch or a horizontal compression. And these are a little confusing. Okay, so let's start with part C. Okay, I'm going to put this one in green. Okay, so again, we're multiplying by 2, but it's on the inside. Okay, so when you look at this, okay, it's going to involve the x coordinate. Okay, because you see 2 times x. Okay, and I'm betting that you think, okay, I need to multiply the x coordinate by 2 and leave y alone. Okay, the x direction here, when you're doing the vertical or you're doing the horizontal stretches and compressions when you're doing the X stuff, you're doing the horizontal stretch or the horizontal compression, it's opposite what you think. Okay, so what this is going to mean, okay, you're going to take the X values and divide by the number in front of X. Okay, so you're going to divide by the number in front of X, which is 2. Okay, so you're going to take each X coordinate, divide it by 2, which is the number in front of X, and you're going to leave the Y coordinate alone. Okay, so like I said, I bet you were thinking that you had to multiply the X value by 2, but you're actually dividing by the number in front of X. Okay, all right, so I'll come out to the side here. I'll do a little thing of new and old points here. So we've got our original points on the black graph. That's going to be -2, 0, and then 0, 2, and then 2, 2, and then 4, 4. Okay, we need to see where those guys get transformed. Okay, if we follow this transformation rule of f of 2x. Okay, so let's try it here. Okay, the point at -2, 0. Okay, we are going to take the x coordinate and divide it by 2. -2 divided by 2 is -1. The y coordinate will stay the same. Okay, so this point gets sent to -1, 0, which is right here. Okay, then for the point 0, 2, which is this guy right here, where's it going to go? You're going to take the x coordinate, which is 0, and you're going to divide it by 2. 0 divided by 2 is 0. Okay, you're going to leave the y coordinate alone. Okay, so this point stays put. Okay, the next point, 2, 2, which is this guy, where does it get moved to? Okay, well, you're going to take the x coordinate, which is 2, you're going to divide it by 2. That's going to give you 1. Okay, and then you're going to leave the y coordinate alone. Okay, so it gets sent to 1, 2, which is right here. And then lastly, 4, 4, where does it go? Okay, so, well, you're going to take the x coordinate, which is 4, you're going to divide it by 2, that's 2, and you're going to leave the y coordinate alone. Okay, so this will get sent to 2, 4, which is right here. Okay, you're going to connect the dots with the same basic shape. Okay, so I'm going to connect each pair of points as I go from left to right with a line. Okay, so we've got this guy, and then they're starting to overlap a little bit, but these two dots would be connected right here. Okay, and then we've got one more. Let's see, hang on, I went too far with that. So connect it here. And then lastly, we can take this point and connect it right here. Okay, and that's it. Okay, this green graph is the this green graph is the graph of f of 2x. Okay, all right. So if you compare the green graph to the black graph, you can see that this was a horizontal compression. We have smushed this thing in the x direction. Okay, so I'm going to go ahead and call this a horizontal compression. Okay, all right, we have one more graph to do, part D, where we're graphing f of 1/2 x. Again, you see that the number you're multiplying, the x is being multiplied by the number, so that means that the x coordinate is impacted, not the y. Okay, so what we're going to do here, and let me see where I wrote this other one. Okay, so I'll just write it below here. Let me get a different color, one that's more visible, because things are starting to bunch up. Okay, what we're going to do here is we're going to take the x values and divide by 1/2. Okay, you're always dividing by the number in front of x. Okay, so we're going to divide by 1/2. Okay, if you divide by something by 1/2, that's the same thing as multiplying it by 2. So however you want to look at it. Okay, so we're going to take the x values and divide by 1/2, which is the same as multiplying by 2, and we're going to leave the y value alone. Okay, and that's going to be for this particular equation. Okay, all right, so let's do our old versus new again. Okay, All right, so let's see here. We got old and new. Let me list these guys out. So we've got negative 2, 0. I'm going back to the black graph. Negative 2, 0. And then we've got, let's see, I've even lost my black points here. So 0, 2, 2, 2, 4, 4. Okay, here we go. Okay, we're going to take the x values and divide by 1/2. Okay, so here we go. If I start with the first point, negative 2, 0, I'm going to take the x coordinate, which is negative 2, and I'm going to divide it by 1/2. Okay, that's going to give me negative 4. Okay, so the new point here will be negative 4. Okay, and the y coordinate will stay the same. Okay, notice what I was saying. If you take the x coordinate, if you divide by 1/2, it's the same thing as multiplying by 2. Negative 2 times 2 is negative 4. Okay, all right, so that's going to be our new point right here. Okay, and then for the original black point 0, 2, okay, we're going to take the x coordinate and divide by 1/2. 0 divided by 1/2 is going to be 0. We're going to leave the y coordinate alone. Okay, so this is a popular point here at 0, 2. Okay, all right, so actually I'm going to go ahead and connect those. Things are getting congested. Okay, so I don't want to lose track of what I'm doing. Okay, those two guys are connected. Moving on to the original black point 2, 2. Where does it go? Okay, well, you're going to take the x value of 2, you're going to divide it by 1/2. Okay, you should get 4. Okay, because 2 times 2 is 4. Okay, so your new x coordinate is going to be 4. You're going to leave the y coordinate alone. So your new point here will be 4, 2. All right, so here, okay, we're going to connect these two orange dots. Okay, like that. Okay, we got one more point to go. Okay, so 4, 4. What happens to it? You're going to take your x coordinate of 4, you're going to divide it by 1/2. Okay, that's the same thing as 4 times 2, which is 8. Okay, so this, your new x coordinate will be 8, and the y coordinate will stay the same. So the last point on the orange graph will be the point 8, 4. Okay, so let's see, here's 8, here's 4. Okay, so about, oops, right here. Okay, so I'll finally connect the dots. I'm just connecting each pair of points with a line segment as I go from left to right. That retains the same basic shape of the original graph. So this orange graph is the graph in part D. This is f of 1/2 times x. Okay, you can see what happened here. Okay, how does the orange graph compare to the black graph? It has been stretched out in the x direction. So it is a horizontal stretch. And that is it. That's how you do these. Okay, so usually when you see these stretches and compressions, either vertically or horizontally, it is going to usually be done with a random graph. Okay, if you use one of those basic functions in section 3.4, the problem is if they stretch out really far. Their y values get really big. Or if you compress them, their y values get really small, so it's kind of hard to see them. Okay, so you can expect that if you're doing these compressions to see a random graph like this. Okay, so just remember, you're going to be multiplying by a number either outside of the function or inside the parentheses. That's going to indicate that you're dealing with a stretch or a compression. If it is a vertical stretch or compression, you are going to be multiplying outside. The number will be outside. You will be multiplying the function by that number on the outside. That affects your y coordinate, and you're going to leave the x coordinate the same. Okay, if instead the number you're multiplying it by x, it's inside the parentheses, that's going to affect your x coordinate. Okay, so you're going to leave the y coordinate alone, and you're going to take the x coordinate and you're going to divide it by the number in front of x.